Right, we're going to kick off into pattern, and this whole section is pattern understanding. We need to understand pattern. Pattern is everywhere, and a major part of understanding pattern is understanding the general core model. So there is a general core model. This is a general core model pattern. And it's all about events. So it's actually a general core model of events. Because that's what pattern is. It's an event of form. So pattern forms are everywhere. They're all around us all of the time, from the micro to the macro. We're surrounded by pattern form, the natural patterns of the universe. But there are very few actual pattern form types. But there's an infinite number of slight imperfections of pattern. And when I say infinite, I actually mean infinite. There's an infinite number of variations to each of the few pattern forms in size and slight imperfections. So it's very hard to measure, but it's not hard to observe once it's pointed out to you, because it's one of those things that's in front of you all the time, and until someone actually points out the relevance of pattern and what's happening all around in so many common ways, you just don't realize it. So what is pattern? We know it's form, but what is pattern? Pattern is form created by pressure between two media, or multiple medias, but mostly just two medias, with an intrusion one way or another to create a form. It's an equipotential boundary where there's pressure one way or another between two different types of media. And that's all it is. But it has so much potential for design because it is everywhere around us. It's the way form is created through the interactions with the energies. So if we compromise, it's not as good as conforming to pattern. If we go against pattern, it'll push back, and pattern will reinstate itself over our straight lines and our square fields and our geometric blocks. Everything is a fractal pattern out there that we can recognize in the universe. Let's have a look at a few. So you have waves. So you have wave patterns, and they're moving if they're waves in the ocean. And they could be waves of sand. This is pressure between a weather event in the air and water. This is wind and sand. It forms sand dunes. They start off as little ripples, they end up as giant sand dunes. There's a few gradations along the way. It's the same with waves. They start off with ripples. You don't see anything smaller than a ripple. You can get blustery surfaces that don't really have a pattern. They're chaotic. But then when you get the right wind, you get ripples, and the storms create massive storm events that harmonize off as swell line waves. So there are different forms of waves. Then we have streamlines. So we get flow going down a stream, and flow events, and they tend to spiral off, and they can actually loop. And they generally flow. So these are looping and the beginning of spirals, but it's the very start, is a streamlines. We also get forms of clouds. So we get clouded shapes. You also get them on top of forests. The forest canopy is a clouded form. So we have cloud forms. We also have, of course, spirals. And this event here with the waves was started by a big spiraling event as a weather system. So we get different forms of spirals. You get very, very tight little spirals. Your fingerprints are a spiral, or they're a lobe. So this is another pattern. There are only 2 fingerprints of all the people in the world. They're either lobes or the spirals. That's all you have. But we can identify you by his fingerprints because there's slight imperfections in all of them. You might have lobes and spirals on each hand, but it's going to be the same on the opposite hand. Lobes on the same fingers, spirals on the same fingers, or you might have a full set of spirals or a full set of lobes, but they're all exactly the same on your hand, but identifiable against everybody else's comparison. There are many types of spirals. There are spirals that come off from a ring, like a weather event, spiral in from a big circular core. There are spirals that go in opposite directions and make a lot of patterns of flower heads. There are growth spirals that gradually increase out, and they're completely measurable. When you measure across this, you find it's a summation series. This is a growth spiral. This is a snail shell, or it's a tendril of a plant. And when you add up these distances across, taking a section straight across the growth spiral, you find it's 1 plus 2 equals 3, 3 plus 2, 2 plus 3 equals 5, 3 plus 5 equals 8. It's a summation. A summation series. They're all identical. They can all be calculated mathematically. It's called the Fibonacci series. So you will recognize exactly a growth spiral because it has that exact form on absolutely all growth spirals. We also have branching patterns. So there are branching patterns, and you have one trunk, and it could be the main course of a river because rivers are branching patterns. And we'll do a breakdown of 3. Then you have a slightly smaller set of 3, and then a slightly smaller set of 9. We're going to break down in orders of 3 here. And then we break down again. So now we've got a smaller set of 27. And to be accurate, we'd have to break down one more time. I'm not going to draw them all in right now. And we break down 3 27s is 81. We break down 81. So they would be smaller and more numerous, and larger and less numerous as you get down to the start of the trunk, out to the first branches, and on down, getting smaller and smaller, but more and more numerous, and actually moving faster and faster. So we have branching patterns. Branches. Your vascular system is a branching pattern. Your lungs, if you cut a section through your lungs, it's a branching pattern. There are branching patterns everywhere, and they go right down from tiny sections of veins in leaves right out to giant trunks of trees, from tiny streams in headwaters right out to the largest rivers on earth. They're all branching patterns. So these are particular patterns that are repeated. There's also scatters. So you'll get scatters, and they're little dotted patterns, and they're different ratios of size, but they're actually a ratio you can calculate. And they look random. They look quite random, but they're not random. They're actually quite precise. You've just got to measure them. So these are scatters. All of these are formed by growth and flow. They're flowing or they're growing patterns. That's what forms these patterns. They're everywhere around us. We have more to add, but they all come out of these or just one more. And that is nets. You also have nets. Now nets are a little bit different because they're formed from shrinkage, lateral tension. The lateral tension of shrinkage. That makes them just that little bit different because the rest of the patterns come from flow and growth. And we need to talk about these nets. Okay, let's look at nets. Mostly nets come in the form of a hexagon. A hexagon will actually join together. It's often used in chemistry actually to describe combinations of elements joined together. Soap bubbles in the bath often form hexagons. Tortoise shells are hexagons. Of course, bees' hives are hexagons. And a lot of nets are variations of hexagons, but they're not necessarily symmetrical. So we get cracking patterns as nets, shrinkage of mud. We get bark on trees are often nets. There are quite a few variations of nets created by tension and shrinkage. And they'll cover a complete surface connected together. So this is quite a common pattern, the hexagon combination. There's one in there in the hexagon that works interestingly as a star. So if we draw across from point to point, we end up with a six-sided star. And then if we pattern that in however we like, what we're actually patterning here is roughly a snowflake. Water freezes in a six-sided pattern. So all snowflakes are six-sided stars, six-pointed stars. And there are no two snowflakes the same. All the snowflakes that are falling now, all the snowflakes that have fallen in history, and all the snowflakes that will fall in the future are a different six-pointed star. That's an infinite number of snowflakes. So that's how pattern is. That's how it works. There are constant forms, but infinite numbers of slight variations. So we see in all the patterns an interesting set of forms that are continually varying. There are spheres, they're not quite circles. So the sphere, planet Earth is a sphere. All the objects in space are spheres. if we look at the objects in space, when they get over 200 to 350 kilometers across, 200 miles across, something like that, they get big enough that their core is hot and molten and they start to spin. And that gravity forces them into a sphere. They actually bulge a little bit at the equator, so they're a bit squashed. That's the centrifugal action of spin. They're spinning around an axis, not necessarily straight. And they bulge at the equators, just a little bit. So again, they're not perfect spheres. But as a shape, as a 3D shape, there is nothing that holds the volume of area, internal volume, to outer cover with a smaller ratio to a larger volume than a sphere. So it's the surface tension of the soap bubbles that hold a bubble as a sphere, holding the maximum amount of mass inside with the minimum amount of surface held together with tension. So it's a very repeated pattern. When you see a water drop plummet into earth, if it's going to hit water, it will actually make a dent and loop back up again. And the drop will rise up above the water. There is a point when it's not going up and it's not coming down. It's actually suspended where it's stopped before it falls back to water, and it at that point is a sphere. So a water drop at the point where there's no tension going down, there's no tension going up, it's just suspended for a split second. You get a photograph of that, and you'll see photographs of this. It's a perfect sphere of water. So this is around the energy and the tension of the water, the surface tension and the volume to mass ratio. And everything we see in the universe out there as an object is a sphere. We also will get spheres within spheres. So we'll get annodations, and they won't be perfect either. They'll be slightly offset, or they'll be slightly crooked. And you can get half circles up against hard surfaces too, so you'll get half circle annotations like this. And you will also get imploding and exploding patterns. And in the 3D, this is just 2 dimensions. They're actually forming like a fluffy sphere, because this is a rounded surface. This is actually a little circle. So these are all part of our patterns. These are all part of our pattern collection. Now we need to talk about one of the core model. We need to talk about this one, like an apple core. This one is the core model of events, and all events and all pattern forms can be found in this core model. Okay, let's look at this master pattern. This is the core model. So, tessellation, a core shape. If you put 2 together, you can tile your way across the ground. In fact, the original tiles were made as tessellations because they're not square and they'll slip a little bit, and it means you don't have to be perfectly symmetrical. But then you can actually be very asymmetrical, and you can change the shape a lot. and stretch away across the surface. And this is how the cracking pattern is with the hexagon, but this is actually easier to draw because it's a quite interesting thing to stretch away across a landscape or a surface, just playing the tessellation game with the core model. Now if we put two together, they're roughly the same size, and we wrap them round each other, you actually make a ball. A tennis ball, if you take it apart on the seams, is two tessellations joined together. So here's the shape that forms the sphere, or the perfect ball if they're perfectly symmetrical, but there's no perfection out there, everything's slightly different. But if you turn that sideways and have a look at that, you get one of these, a yin-yang pattern. And then if you overlay that with another one, you get one of these, which is a swastika pattern. And then if you go the other way and you overlay one of these, you get one of these, which is the infinity pattern. And then if you go one more, you get one of those, which is actually the tessellation and if we just separate it a little bit, it's like a giant tree with the canopy almost coming to the ground and the root net almost coming to the surface. And that's what a tree is. That's how a tree pattern is. It is the core model. These are the symbols of humanity that have been a representation of nature in its most concise form. And any traditional people that have worshipped nature have always had these patterns representing the different forms. So here we can see a very traditional representation. Here we see a tessellation across the surface. There's our core model starting to emerge as we slightly separate this one here. But let's have a look at your backbone and all invertebrates' backbones. They are all a set of tessellations. There's a backbone. Here is your shoulder bone, right here. In fact, your leg bone and your joints on your knee going down to the joints on your ankle and all the way across your feet, they're all tessellations. You are a set of tessellations in your skeleton, three-dimensionally jointed into a three-dimensional set of joint tessellation connections. So from here we can start to look at how does the energy flow through a system like this? If this is a flow of energy, how does that work? Well, there's actually a detonation point here, like a seed germinating with a tree. It's actually exploding out as a detonation away from the origin. And there are energies coming through the living explosion. It's a living explosion. But all explosions are like this, because in the 3D, this is a torus. This is a cross section I'm drawing here. So if this is an explosion, it's actually exploding like a donut in all directions. It's torusing from the center out. So it's literally like a donut with a point of origin and energy coming up and then torusing in all directions away. So when we look at a tree, there are gathering points from one side coming right through to the other. So, and through the point of origin. So you find that a tree, if we look at it actually as a circle, it has a gather of, is a streamline of nutrient coming from the roots through the point of germination and over to the opposite side of the branches. And there we have, we've scribed that same pattern again. We've scribed the yin-yang pattern from one side to the other. And you're going the opposite way through the point of germination to the other side. And here's the infinity pattern coming up. And it's at the point of germination that minerals going up and sugars coming down in two different directions spiral through streamlines. So this is actually spiraling. So we've got the outside to the inside, from the inside to the outside, from inside the roots to outside the branches, from outside the branches to inside the roots, traveling through the point of germination where the switch point occurs. And these are spiraling events. Sugars going down, minerals going up. Streamline curves coming through. If you track the flow, this is exactly what's going on. That is exactly what happens in an explosion. But with a tree, it's a productive explosion. It actually produces wood, it produces material. Top to bottom, it is collecting and distributing. So it's going in and it's going out. It's going out and it's going in. This is actually quite common in nature. Water and gases, in this case, going in both directions. There's a two-way trading around the extremities. Around the extremities, there's a two-way trading event around the edges. And we're going to do a lot of edge thinking in this course. I'm going to start to talk to you about edges pretty soon. And the boundaries and why boundaries and edges are so important and where so much trade goes on. So this is the same pattern in a tornado. This is the same pattern in whirlpools. This is the same pattern in trees. This is a core pattern. We can find, by dissecting this pattern, we can find waves. By dissecting this pattern, we can find spheres. By dissecting this pattern, we can find scatters. Of course we can find branching patterns, it's tree, right? But it's the same in a whirlpool, it's the same in a tornado. There are so many patterns that make this same form, and when you cut sections through them, you can find all the known patterns. The tree rings, when you cut the trunk, the tree rings actually record drought, they record fire, they record wind by being offset, they record changes in weather because of the pressures scribed and left behind with the spherical shaped ring. And trees themselves are ascending spirals of branches and branchlets, 2 leaves. So here, you need to start to understand the importance of pattern, and I better put an N on the end of pattern, because it's not patter, it's pattern, and realize there is a core model pattern at the center of this understanding.